Hey guys, in this video we are going to review the machine learning concept. As you may know, machine learning is a member of a bigger family called AI. Machine learning, deep learning, and natural language processing are members of this big family. Artificial intelligence is basically the science of enabling a machine to sense, learn, reason, and act. And the members of artificial intelligence family are machine learning, neural network, or deep learning. Basically any neural networks that has more than 3 layers is called deep learning. Fuzzy logics, robotics, expert systems, and natural language processing. So all of these members are members of artificial intelligence family. And any artificial intelligence is based on an input data, a program, a machine that learns the program and applies to the data and give us an output. As I mentioned, the machine learning, the supervised version actually has a data, a program, a machine, and output. And it gives us a learned function, which we call model. And we can add new inputs or test data to the learned function or model, and it gives us the new output. There are 2 categories of machine learning, which we're going to explain in this step, which are supervised learning and unsupervised learning. In supervised learning, we have an input, or here is called X. We feed the input to our model, and we have some examples to learn from or correct labeled output. So we add an input and output, and the machine has the time to learn this model. And in the next step, there are some new inputs or test data, and the machine is able to predict the target or the new output or Y. The classification output, so we had, as you may remember in the previous video, we had 2 subcategories of supervised learning, which are classification and regression. In classification, we have the output is distinct value, and in regression, the output is continuous values. On the other hand, in unsupervised learning, we don't have any correct labeled output, or we don't have any label for our output. We simply ask the machine to detect an interesting pattern in unlabeled data. One of the most famous unsupervised learning algorithms is clustering, and as you can see in this example, there are 2 distinct clusters, and the machine has been able to detect these patterns among the input data. So there is no learning in the unsupervised learning, and the machine is supposed to explore the pattern in the input data. Now let's explain the cost function and gradient descent using linear regression. Linear regression is one of the most famous regression models, which is very simple. There is an input data, and we have a model or line that maps this input data. Here we have an example of Apple stock wars during the year. So the horizontal axis is months, and the vertical axis is worth of a stock. And this line here, the black line, is our model or our linear regression. Here you can see our input data or feature variables and target variables. So we have an X or input and a Y-axis or target variables. And we have our test data, which is the month of December, and our target variable, which the machine needs to predict. So, as I mentioned, the train set has features and targets. We're talking about supervised learning. So, we have provided the machine with some examples of features and targets, as you can see in this table. And the machine learns from these examples, and we have a learning algorithm or function, which is fx. And in the next step, the new input is fed to the model, and the machine is able to predict the new target. Here we call the predicted target y hat. And y hat is basically an approximation or estimation of the real y. So, for example, we want to estimate the Apple stock worth in a specific month, and we predict this apple-stock words, such as this point here. And based on our model, the predicted worth of the stock is y hat. So here in this point we have y hat. Okay, but the real output is something in this point. Okay. Now let's assume that our model is a straight line. Okay. We have the simple line equation here. We just want to have an equation for our model. So fx is wx plus b. W and b are parameters of the model, and wx plus b is a simple line equation. Okay, and having this line, we have an error. Our error is basically the real y minus the predicted y minus the predicted output, or y hat. So as I mentioned, the error is the real y minus the estimated output, or y hat. The cost function is the average squared error, means the sum of all predicted y's minus the real y's, or real outputs. So we have these real outputs and these points on this line which are predicted, and the average squared error is the average, so 1 over the number of data points, or m, or number of training examples, multiplied by the sum of y hat, or predicted output, minus the real y to the power of 2. And here you can see the formula for cost function. We divide it by 2 to make it more simple. So j, w, and b is equal to 1 over 2m, summation of y hat minus y real over 2. This is called average squared error, or cost function. And considering the cost function, if we plot the w, or weight parameter, considering the cost function, we have a U-shaped diagram. And the mean point of the cost function is here. Now, based on these explanations, let's define the gradient descent. So, the goal is to minimize the cost function in any machine learning model. The goal is to minimize the cost function. And let's assume that we're in this point and we're moving toward the mean of cost function toward this point, or local minimum. So we have the new w. You can calculate the new w based on this formula. W is equal to w minus alpha, or alpha is the learning rate, multiplied by the derivative of the cost function. So the new weight is equal to the old weight minus the learning rate multiplied by the derivative of the cost function. And the second parameter we have in our cost function, b, is equal to b minus the learning rate multiplied by derivative of cost function. And we continue or repeat these steps until convergence. Convergence is defined by reaching a minimum where parameters w and b don't longer change much with additional steps. So starting from any point in the cost function diagram, we move downward till we reach the minimum or local minimum value. Now let's explain the learning rate. If alpha is too small, alpha is basically the learning rate, or the number that is decreased from w, or weight, and b. So if alpha is too small, the steps that we take toward the minimum cost function is tiny, or we have tiny steps, and it takes too long for us to reach the local minimum. And in case that alpha is too large, we may lose the local minimum. I mean, we may reach the point and we may pass the local minimum and shift to the other part of the diagram. So it's very important to choose the learning rate wisely. Now let's define bias and variance. Bias Look at this diagram here. Bias is the inability of machine learning model to capture the true relationship in the data set. So as you can see, we have a curved model here, but we have a curved data set here, but our model is a straight line and it cannot map our data set properly. So this concept is defined as bias. And variance is basically the difference between the model and the data. So these green distances you can see here is the difference between the data sets and our model. These are called variance. The underfitted model performs bad on the train and the test data. As you can see, the model cannot map the data set properly, and it has performed badly on the train and the test data set. And we have the overfitted model. It can perfectly work for the train data set, but as it's too perfect for a specific data or input data, it doesn't work out for any other output or the test data. So the overfitted model works perfectly in the train data set, but it works very bad in the test data set.